Hey everyone, it's Miss Velius. We're here for another exciting math lesson. Our lesson today is an exciting one. Today what we're going to be doing is we're going to be taking all of the information that you have been learning about LCM and GCF and apply it. And you might be saying, well, Miss Velius, I've already been applying it. I can solve those problems. Well, today we are going to be looking at specifically word problems. Now, if you're anything like me, when I was a young mathematician, I really struggled with word problems. And word problems are something that you really do have to take your time with. And I'm going to show you some strategies today so that you can be the best mathematician that you can be with a little practice. So here we go. Today we have an essential question like we always do. Our essential question is, well, how do I know when to use LCM and GCF? We have a goal, and by the end of the day or the end of this lesson, our goal is that we'll be able to start that process of beginning to know which method we're going to use. Do we need to use the LCM? Do we need to use the GCF? Now, in order to do any of that, we have something called the problem-solving plan. So with any word problem, you are going to be using this same plan, and this plan is helpful because it really starts getting us to use those strategies that we're learning in reading and pulling evidence out of our reading in order to solve math. So what is this plan? Well, there's 3 steps to it. And the first question that we're going to ask ourselves is, what do we already know? In any word problem, there is information that you are already aware of. We're going to highlight this stuff with pink today. And if you're using Notability at the top, you have a highlighter and you can choose pink. And what are some things that you might know in a word problem? Usually the things that you know are things like numbers, measurements, and quantities. Oftentimes we highlight the number and like what is the measurement of. So it might be like 3 feet or 6 dogs or whatever it happens to be. The next part of the problem-solving plan is to figure out, well, what is the question asking us, or what do I need to know? And today we're going to highlight using yellow. So you might be asking yourself, well, Miss Avelius, how do I know what I need to know? Well, usually the things that you need to know are things like missing information, or sometimes it specifically just says, this is what you're trying to do. The last part of our plan is to ask yourself, well, what's my plan to solve? The good thing about this is that oftentimes there are multiple ways of solving a problem, so you just need to come up with a plan, but figure out why that's what you're going to do. So this is where we're going to use those reading strategies, and we're going to literally ask ourselves, I am going to do what because the text is telling me to do this. So let's give it a try. First, what we're going to do is we're going to fill out a chart specifically for LCM and GCF. You have a chart that looks like this, and we're going to go ahead and fill it out. So if I am looking for an LCM problem, inside of my LCM problem, I might be asked to find an event that continues to happen. That continues to happen piece is my clue that I'm looking for an LCM. You might also be purchasing multiple items. The big one that I come up with is that hot dog problem. Hot dogs are sold in different size packages than the buns. That's weird. It happens. So you might be asked to purchase something. If you're purchasing things, you're purchasing a multiple of things, so we're looking for that least common multiple. Another thing is figuring out when something is going to happen again. So again, when you're looking at time, time is always reoccurring. It's over and over and over. Time is infinite in some capacity, but time is infinite, so are multiples, so we're looking for multiples. Oftentimes, you're just looking for those key words that hit you in the head of, I'm looking for the least of something. So fewest, smallest, shortest, next. Okay, now, what's telling me that I need to find a GCF? Well, the first clue that I have is if I'm ever splitting something up or out into smaller, even groups or sections. That splitting should be your key word, that you're taking that number and you're splitting it into a smaller number to use. You're finding those factors. You might be distributing sets of things. There's oftentimes questions about teachers distributing papers and pencils or school supplies. You might be arranging things. I know a lot of our GCF questions have something to do with arranging bouquets of flowers or balloons. Again, you might just simply be told in the problem that you're looking for the largest or the greatest or the most. When you see those, that should trigger that greatest common factor, least common multiple. If you need to pause this so that you can finish filling out your chart, now's a great time to pause before we move on to our first example. We're actually going to move on to our first example this time. Okay, here we go. Example number 1. All right, Samantha has 2 pieces of cloth. One piece is 72 inches wide, while the other piece is 90 inches wide. She wants to cut both pieces into strips of equal width that are as wide as possible. How wide should she cut the strip? Okay, so what do we know? We know that Samantha has 2 pieces of fabric. We know that one is 72 pieces, and we know that the other is 90 inches. Now, what do we need to know? Well, I need to know that she's cutting, and she's cutting them equal width, and we want to know how wide are those equal width strips of fabric going to be. So let's start thinking about what is our plan. So I'm going to use my chart that we just made. Cutting, that was GCF. So my plan is I am going to use the greatest common factor of these 2 numbers. And I'm going to use this, I know this because I'm cutting or dividing up the strips of 72 inches, there's a factor, and there's that word common, 90, into as wide means greatest, pieces of fabric that I can. So I've got it all in there. I've got greatest, wide, common, and factor of 72 and 90. So let's do it. I'm going to list out my 2 numbers, and I'm going to start listing my factors. You can also use the cake method or the factor tree. I'm going to list and compare. So I have 1 and 72, 12, and I have 8 and 9. Let's do the other one. I have 1 and 90. I have 2 and 45. I have 3 and 30. I don't think 4. Nope. 5 and 18. 6 and 15, and then I also have 9 and 10. Well, now we just have to compare. We've got them all listed out. I know that there's nothing in between 9 and 10. There's nothing in between 8 and 9, so I've listed out all of my factors. So let's compare them. Which is the highest one that they have in common? That's 18. Well, Samantha can cut strips that are 18 inches wide. That's the widest she can cut them without having leftover inches. So example number 2. I gotta read it again. I don't have it memorized. So Ben exercises every 12 days and Isabel every 8 days. Ben and Isabel both exercise today. How many days will it be until they exercise together again? What do I know? I know that Ben exercises every 12 days. Isabel exercises every 8 days. Both Ben and Isabel exercise today. Okay, so what do I need to know? Well, I need to know how many days will it be until they exercise again. So I'm going to go back to my chart. Okay, something is reoccurring. That means I'm looking for multiples. Okay, so my plan, I'm going to use least common multiple. I know this because we're trying to figure out when is the next least time the 2 common friends will exercise again on the same day. Multiple. So let's do it. I'm going to list them out, and then I'm just going to list out my first 5 or 6 multiples of 8. So 8, 16, 24, 32, 48. 12, 24. 36, 48, 60. And now compare. What's the least common that they have in common? Well, 24. So they will exercise together again in 24 days. Let's also summarize. So I want you to pause the camera and I want you to summarize. Summarize what I talked about. Summarize what is going to stick with you so that when you're starting to do independent work, which you're going to in a minute, you know what to do. Pause it now. All right. I hope that you have a summary down. I think if I were a student, I would have said something to the effect of, in order to solve LCM and GCF word problems, I need to remember keywords. I need to pull out what I know, and I need to figure out what I need to know in order to make a plan. Don't forget to do that seesaw practice. You're great. You're amazing mathematicians. You're going to be superb. Hope you have a great day. We'll see you later. Bye.